Good day, class. Today we're going to begin our look at a very specific differential equation called the linear differential equation of the first order. This equation will always be of this exact form. Here, P and Q are functions of x only. When we have this type of equation, we can use an integrating factor in order to solve for y. So here I've identified the main steps. The first thing to do is identify P and then determine the value of an integrating factor equal to e to the integral of p dx. Okay, so you make sure first that your equation is in this exact form so that you can determine P, and then you can work out e to the integral of p dx, and that is called your integrating factor. Once you know your integrating factor, you multiply all three of these terms by it. And when you do that, it'll look exactly like this. You can see that e to the integral of p dx has been multiplied here by all three of these terms. Here is why we work out that integrating factor. Once you have done this multiplication, the left side will always be equal to the derivative of that integrating factor multiplied by y. And let me just show you that this would be true. You can consider this to be a product, and therefore in differentiating it, you would use the product rule. This is your u and this is your v. And then we have u times the derivative of v plus v times the derivative of u. So the derivative of y is simply dy. The derivative of the integrating factor is all of this. So when you differentiate an exponential function, of course, you repeat the exponential function and then you multiply by the derivative of the exponent. And the derivative of the integral of p dx is just p dx. Okay, so the important thing to note is that this left side will always be the derivative of the integrating factor multiplied by y. Okay, so once we have this form, what we do is we integrate both sides. So when you integrate that left side, then you'll always have the integrating factor multiplied by y. And then we have to make sure we correctly integrate the right-hand side. And when we're done, we solve by y simply by dividing both sides of the equation by the integrating factor. Okay, that may seem confusing, but what we're going to do is go through some examples together now. So I'm going to do 4 with you in this first video, and then there will be a second video as well. Okay, so I'm going to take the questions from your textbook from exercises 31.4, and I've selected some that we'll do together. Okay, so the first one we're going to do is problem 4. Okay, so you can see it's here. dy plus 3y dx is e to the negative 3x dx. So the very first thing we have to do is compare it to this equation here. So you can see that it compares very well. So the first term is identical. In the second term, we have y, and then we're supposed to have p dx. And so we have a 3 and a dx. Okay, the right side, this would be q. And of course, you'll note that both p is 3, by the way, and q is e to the negative 3x. They are both functions of x only as required. okay? So p is actually a constant, which can be considered a function of x. Q is also a function of x. Okay, so let's get started. We have to identify p and determine the integrating factor e to the integral of p dx. So in this case, p is 3, okay? Because it's not the y and it's not the dx. So p is 3. Okay, so we start like this. P is 3. And then we work out the integrating factor. The integral e to the integral of p dx becomes e to the integral of 3 dx. And now all we do is we make sure we perform that integration. So the integral of the number 3 with respect to x is 3x. So this is now the integrating factor. Okay? So then we would be multiplying all terms by the integrating factor to obtain this expression. And then once we integrate both sides of the equation, we get this. Okay, so I'm actually going to start right here. So I'm going to not write out this step here because often I find that it's more confusing to include it. So we're going to start here. We're going to write the integrating factor multiplied by y equals, so let's do that. The integrating factor multiplied by y equals, now look at the right side. We need the integral of q times the integrating factor with respect to x. And remember, q in this case was e to the negative 3x. So we need the integral of q multiplied by the integrating factor with respect to x. So this is the integral of q. This right here is, of course, e to the integral of p dx, and here's the dx as required. Okay, so now we have to work out this right-hand side integral. So first we should simplify this. E to the negative 3x multiplied by e to the 3x becomes e to the 0. And that's because when you multiply powers of the same base, you add the exponents. So what we have now on the right-hand side is simply the integral of the number 1 with respect to x. And you know that that's equal to x. And of course, we still have a constant. So x plus c. So all we have to do now is the final step. Okay, so we've done this. We wrote the left side like this. We wrote the right side like this and performed the integration. So now all we do is isolate y. So how do we isolate y? We divide by e to the 3x. So y is x plus c divided by e to the 3x. Okay, and that's fine as your answer, but more often you might see it written like this. Okay, so y is e to the negative 3x times x plus c. All right, so that's the first question done. So this is going to take some getting used to, I know. So that's why I said I'm going to do lots of examples with you. So let's go on and look at problem 6. Also from your textbook. Now a little bit tricky here because we have now the independent variable t and the dependent variable I. So this replaces x and y respectively. Okay, but we can still compare with this form and we should be able to figure out the value of p because remember the first step is to identify p. So p is what y and dx are multiplied by in this term right here. But in this case, it would be what I and dt are multiplied by. So here's the I and the dt. There is nothing else in this term. So that means P is equal to 1. So we have P is 1. And the integrating factor is normally e to the integral of P dx. Well, it'll simply be e to the integral of P dt. And specifically here then, it's e to the integral of 1 dt. And when you integrate 1 with respect to t, you get t. So our integrating factor is now e to the t. So that's our first major step. And then remember, we're going to go and write this out now as the solution to the equation. So left side, integrating factor multiplied, now this will be an I, so our integrating factor is multiplied by I on the left side. So it's e to the t times I equals, now on the right side, we need the integral of q times the integrating factor and dt. So the integral of q, all of this is q. Okay, so everything, take a look, everything in this term except for the differential is q. So all of this is q, e to the negative t cos t, that's q. So we have the integral of q multiplied by the integrating factor and then a dt. Well, the integrating factor is e to the t, so multiplied by e to the t and also a dt. So this is the integral of q, integrating factor, or e to the negative p dt, and the differential dt. Okay, and so just like we did in the previous question, before we integrate this, we will simplify. So e to the negative t times e to the t is e to the 0 or 1. So we get 1 times cos t dt here. Okay? And now we have to integrate the cosine of t. And hopefully you've got your formula page. The integral of cosine is sine. So this is written sine of t plus c, like that. And so the last thing to do is to isolate that dependent variable I. And so that's done simply by dividing by that same integrating factor like this. And that can also be written like this. Okay, so I hope you can start to see the steps involved and that they are starting to make sense. Again, you have to figure out what is P and then work out the integrating factor. The left side is always going to be that integrating factor multiplied by the dependent variable. Integrating factor multiplied by the dependent variable. On the right side, you will always need to integrate Q after multiplying it by the integrating factor. So Q after multiplying it by the integrating factor. Here as well, Q after multiplying it by the integrating factor. So after the multiplication is done, you simply integrate and then isolate that dependent variable. Okay, let's continue with another example. So this is problem 8. Now the striking thing here is that it does not resemble this equation yet at all. So we're going to see if we can make it look like this equation. So first thing is I'm going to multiply all terms by dx. Okay, so that's a little bit better. What else has to be done? Well, the term containing y, okay, which is this term, has to be brought to the left side. So we'll do that now. So 2 dy plus 6y dx is 5 dx. Okay, so of course I changed from subtraction to addition. Now let's have a look. We're quite close. The only thing we have to do now, this has to be 1 dy here, not 2 dy. So what I'm going to do now is divide the 3 terms by 2, and then I will have the perfect setup. So this will be dy plus 3y dx. And here, 5 over 2, or 2.5 if you hate the whole fraction business. Okay, and now let's take a look and compare. So the setup is perfect, and we should be able to identify what is p. So take a look at the term here, and you should see p is 3. What is q? Take a look at this term here. You should see q is the number 2.5 or 5 halves. Okay, so now we know what p is, and we work out the integrating factor. So since p is the number 3, then our integrating factor is e to the integral of 3 dx which means it's e to the 3x. So our left side then is e to the 3x, that integrating factor, times y. Equal sign on the right side. Start with the integral symbol, then write down q multiplied by the integrating factor and the differential dx. So q is 5 halves. We have to multiply it by the integrating factor and the differential dx. There we go, we're all set. Okay, so it's the integral of q e to the integral of p dx dx. The integral of q e to the integral of p dx dx. Okay? All right, so all I have to do is correctly integrate this. Yeah, so this is done. The 5 halves just stays there as a multiplier. And you know, I think, that when you integrate e to the 3x, e to the 3x is repeated, but you multiply by 1 over 3. So it's the integral of e to the 3x is 1/3 e to the 3x. And then here, of course, we have a constant. Okay, so again, the derivative of e to the 3x would be 3 times e to the 3x. But the integral of e to the 3x is 1/3 e to the 3x. So that 1/3 can be multiplied by this 5 halves to give us 5 over 6 e to the 3x plus c. Okay, so how is the answer obtained? We need to isolate y, so we simply are going to divide by e to the 3x. So we get 5/6 e to the 3x plus c divided by e to the 3x. And that can be written like this. So each term is divided by e to the 3x. So the first term will just be 5 over 6. Then we'll have plus c times e to the negative 3x, like that. Oops, oh, and that should say y equals, right? Right here, when I divide by e to the 3x, we write y equals, showing that that is what's left. Okay, and that's perfect. Y is 5 over 6 plus c e to the negative 3x. Sometimes the textbook does something strange here, like factors out 1 over 6 from this constant. But I'm happy with you just leaving it like this. Okay. I should show you though what I mean, so that if it does come up, you won't be confused. So I'll show you that, okay? So do I have, oh, another paper. So let me just show you what I mean, okay? I don't need you to do this on your test or anything, but okay, so what we have right now is y equals 5 over 6 plus c e to the negative 3x. So what the textbook does is calls this a different constant c1 now, and takes 1 over 6 out of both terms, leaving here 5 plus, I guess this would then be 6c1 e to the negative 3x, and then makes this the final constant here, c e to the negative 3x. So the value of c here is 6 times the original c1. Okay, so just be aware that this is done sometimes with the textbook answers, okay? But that I don't want you to do that at all, and that I am perfectly happy if you stop right here. So all you have to do is divide by e to the 3x like this, and the best way to do that is to split this into 2 terms and write it this way. Okay, all right, so I'm gonna do one more with you in this video, and then there will be a second video as well. So let's take a look at number 10. Here's what we have. We have x dy plus 3y dx is dx. So let's take a look and compare it to our general form and see what needs to be done. I'm hoping you can see that we need to divide all terms by x, because this must simply be the differential dy. So I'm going to go ahead and divide the terms by x. When I do this in this term, I'm not going to put the x under the y or the dx, because I want to keep those clear. All right? Okay, and I'm not going to put them under the I'm not going to put the x under the differential dx here either. So I'll show you what I mean. So to divide these terms by x, I'm just going to write 3 over x times y dx. And here then, if this is a 1 over x dx. And I've done that, just let me move this up. I've done that so we can clearly see then, oh, p then is 3 over x. And here, q is 1 over x. Okay, so just keep the y and dx as they are. Same thing here, the dx as it is. If you have to divide by x, do it this way, 3 over x and 1 over x, respectively. Okay, and now I'm going to go about and carry on by identifying P. P is 3 over x. What is the integrating factor? It's e to the integral of p dx, which means it's e to the integral of 3 over x dx. Okay, this is going to get interesting. What is the integral of 3 over x dx? It is 3 ln x. Okay, so what does that mean now? That means the integrating factor is e to the 3 ln x. But since we know the natural logarithm is the inverse of the exponential function, this can be simplified. The first thing we do is we take the 3 here, which is the coefficient, and we make it the exponent on x. So this integrating factor now becomes e to the ln of x cubed. So that's a property of logarithms. The coefficient here becomes the exponent here. And then e to the ln of x cubed becomes x cubed. So these functions, the exponential function and the natural logarithm, are inverses. So when we have e to the ln of x cubed, this simply becomes x cubed. So this now is the integrating factor. Okay, so it goes here to here to here, then here and here. And now we know our integrating factor. All right, so what does this mean? This means that our left-hand side becomes y times the integrating factor. And the right side is the integral of q, so here's q, multiplied by the integrating factor, and dx. So this is the integral of q times e to the integral of p dx times dx as required. Q times the integrating factor and with respect to x. Okay, so remember that before integrating, we perform this multiplication. Well, 1 over x multiplied by x cubed is the same as x cubed divided by x, and therefore it's x squared. What is the integral of x squared? It is 1/3 x cubed, and then of course we will have here plus c. Last step, isolate y, and how is that done? That's done by taking these terms and dividing them both by x cubed. And so what does that give us? So 1/3 x cubed divided by x cubed will be 1/3. Then we'd have plus c over x cubed, which we could write c over x cubed, or we could write it cx to the -3. And that's perfect for me for your final answer for y. Okay, now again, the textbook might do that strange thing where they would common factor 1/3 out of both of these terms as well. And again, I'll show you how that would work, but it's not necessary. So here we go. This is our final answer, which I am very happy with right here. Okay, so that's what we got for our answer. Just be aware that the textbook might do this strange thing. Take 1/3 out, leaving this with 1 plus. This then has to be 3. Okay, so they would have named this C1. 3C1 x to the -3, like that. And then this 3 times the original constant, they would call the final constant, like that. And they might leave it like that, or they might leave it with the x cubed underneath here, okay? And so just be aware that I was perfectly content with the way that we wrote the answer here instead. Okay, so I'm gonna stop the video and upload it, and then make a second video where I do 4 more examples. Okay, thanks a lot for watching.